2.3 is graphing equations of lines. Yay. You guys remember what is the standard form of equation of a line? What do you think it is? What? I know that we're going to talk about functions, but yes, f of x equals x is like a standard, very standard equation, apparent function of a linear equation. What is the standard form of a linear equation? You guys remember that y equals mx plus b. We're going to go over that today. So parent functions are something that won't go away. A parent function is the most basic function of the family, the most basic formula of a graph, okay? And we're going to take a look at them with everything that we graphed this year. So f of x equals x. This says the function of x equals x. When I input something, this is what tells me I'm inputting to x. So if I input a 1, that means I'm putting a 1 in where the x is on the equation. This technically says y equals x. It's the same thing, okay? Y equals x or f of x equals x is the same thing. You're going to see it written in function form a lot more this year because we're going to start training our brains to do that. When you graph this basic function, okay, your slope is simply 1 over 1, okay? So this is 0, 0 is your y-intercept because there's nothing added on here. And you go up 1 over 1, or you can go down 1 over 1. And your graph goes straight through those points. And I'm going to pretend that my graph is perfect because I don't have graph paper to make it perfect. So on your homework, you're going to want to have graph paper. You're going to want to have a straight edge so that you can draw straight, perfect graphs for me and not confuse yourself. Okay. In general, a y-intercept of a graph is the y-coordinate of a point where the graph intersects the y-axis. So in this case, my y-intercept is 0. And the reason it is 0 is because there is nothing being added to this equation here. So my y-intercept is 0. That's what makes it a parent function. It's literally the most basic starting point of a graph. Then you move to graphing different types of equations and comparing it to the parent function. So we want to graph the following equations and compare to y equals x, which is the parent function. You're going to have to get used to this terminology when they're asking you to compare something to the parent function. So on your homework, you can do it one of 2 ways. You can graph 2 separate things and explain it in words, okay? You can graph it on the same graph in 2 different colors and explain it in words. Those are your 2 options, okay? So if you have y equals 2x, okay? How would I set up that graph? Where would I start? What would I do?
Start on where your slope is. So
No, you start at where your y-intercept is. What's my y-intercept? Is there one? It's 0 because there's nothing being added to this graph. Now, that's my y-intercept. Now I can go off of my slope. What's my slope? 2. So I'm going to go up 2 over 1, up 2 over 1. Okay? Or I can reverse it and I can go down 2 and over 1 to make my line. Okay? So here is the graph of that equation. Now, we're not done because it says I want you to compare it to y equals x. Well, this is my graph of y equals x. Where does y equals x start? What's my y-intercept? 0. What's my slope?
Point.
So it's gonna go up 1, over 1, up 1, over 1, okay? Or down 1, over 1. So do you see the difference in this line? Okay, this one is getting larger quicker, okay? This one is my standard form. So when I go to compare, I would say something along the lines of y equals 2x when compared to the parent function has a growth rate two times two times more than y equals x. Okay, so this on the outside tells my growth rate, tells if it's expanding or if it's shrinking. So that 2 tells me that I'm growing exponentially twice, or I'm growing 2 times more in that graph. Okay. D looks like this. It says, same instructions, compare this, graph this, and compare it to the parent function. Y equals x plus 3. What am I going to do to graph that? Where does that one start? What is my y-intercept?
3.
3. 3, 0 is my y-intercept. So I'm going to start here. And then what is my slope?
1.
So up 1, over 1, up 1, over 1. Okay. Here is my line. Now, I have to still compare it to y equals x. What is my parent function intercept again?
0.
0, and my slope is
1.
1, 1, 1, 1, 1. Okay. So then I have to compare these lines again. Okay. Y equals x plus 3 has a different y-intercept by 3 positive units compared to y equals x. So on your homework, when it asks for you to compare them, I want a written description as well as a graph. Yes.
Do we also have the parallel?
We don't, these might not be parallel to be honest, because, well, wait a second, their slopes are both 1, yes?
Yes.
So they are parallel. You are correct. You can write that in there too. Also, the lines are. Yeah, good. So when you graph those, make sure you graph them with a straight edge so that you can definitely see that. But yes, so that's what you're going to do on your homework tonight. You're going to graph both, and then you're also going to write a written statement about both, because I want to see that you can comprehend what's happening, okay? Besides just graphing them, I want to see if verbally you understand. Because sometimes we can do the verbal part, but we can't do the graphing part. So it helps me know that you actually know what's happening, you just can't graph, or vice versa. Okay. So yeah, that's where we're going to start, and then we are going to continue into slope-intercept form. Okay, slope-intercept form. And slope-intercept form is y equals mx plus b. You have to have that memorized, because on the test and quizzes and things and throughout this whole year it's going to say put something in slope-intercept form. So I need you to know what that looks like. Okay? The m is my slope and the b is my y-intercept. Okay? So then I can graph things very easily if I get it into that form. Using slope-intercept form to graph. First, you write the equation in y equals form. Then you identify the y-intercept. You identify the slope. You draw a line. So if I want to graph y equals negative 2/3 x minus 1, how would I start that graph?
You would go down 1.
Yes, I would start at negative 1. That's my y-intercept. Then what am I going to do?
You left 2, then left -2, and then up 3.
Down negative 2,
Up 3.
and then over 3. It's rise over run. So if it's negative, I'm going down 2, over 1, 2, 3. Okay? I can reverse it and go up 2 and to the left 3 also. Is that what you were saying, Jason? Okay. So then I have graphed this line. What happens if I want you to graph something that is in this form? What happens if I say graph 5x plus 3y equals 7? No, equals 6. What are you going to do?
Subtract -3 or 3.
No. Here's why I don't want to subtract negative 3. I want to get everything away from y. So what do I want to subtract?
6.
No, 6 is on the other side of the equal sign. 5. Let's subtract 5x so that it says 3y equals negative 5x plus 6. Now, I'm basically into this y-intercept form. All I have to do now is do what to get rid of the 3? Divide it. Good. So then I divide it and I get y equals negative 5/3 x plus 2. Now I can graph because now it's in y-intercept form. So where do I start my graph at?
2.
At positive 2. That's my y-intercept. Good. What is my rise over run?
Down 5 over 3.
Down 5 over 3. 1, 2, 3, 4, 5. 1, 2, 3. I can also go up 5. 1, 2, 3, 4, 5. Go to the left 3 and get my other point. So then I have a graph that looks something along these lines. Okay. And I've graphed that. So if it is not in y-intercept form or slope-intercept form, you have to get it into slope-intercept form first. You want to get y by itself and graph that. Last two, just little questions. How would you graph these? How would I graph those? These are two separate graphs because they're not in any particular form. So how do I end up graphing those? How do you graph y equals 2?
Go up 2.
You go up 2. Okay, what do I do from there?
Just draw a line across.
Across horizontally. So when I have a y graph, or just y set equal to one thing, it's a horizontal graph. Which means for x equals -3, I'm going to go to -3 and I'm going to create a vertical graph. Okay? And so today, when you're graphing, this is the stuff we're working on for graphing. we will see how it goes on Monday. Maybe review it a little bit and then take a quiz over 2-1 to 2-3. Or take a test over 2-1 to 2-3, something